What do you got? You gonna
I'm
reply?
about to send you.
You sending me something?
You're about to send you something.
Okay.
1 moment.
When's your final, Taylor? Is it soon?
My final, this is how my teacher does it. He has an end of the quarter on the exam this upcoming Tuesday, and then my finals a week after the Tuesday.
Oh, okay.
And how the quarter exam on Tuesday works is that whatever I get on that makes up for my lowest quiz grade.
Okay. Which one are we starting?
And then my finals the fall. I'd like to start on 45A.
I see a 45. Is there an A or just a 45? I don't see anything above 45.
Pretty much 45. The instructions are finding the tangent.
At P?
The tangent to the curve at P.
What's the point Q for?
I have no idea. Oh, that's for B. The horizontal tangent to curve at Q is for B.
Okay. All right. Let's see if we can set this up here. Hold on a second. So we're going to take the derivative of this function and evaluate it at pi over 2. That's all we're going to do. Okay? So let's take the derivative of it. What is y prime?
So right now I just have pi over 2.
I'm sorry?
So right now I'm just working with pi over 2.
No?
Oh, y equals 4 plus
Of this function, yeah. In other words, both of these lines, these red lines, are slopes of tangent lines. So you can be about 90% certain that the first step in any calculus problem is going to be take the derivative of the thing. So if you don't know what to do, that's always a good starting spot. So what's y prime? What's the derivative of cotangent?
I believe that is negative cosecant times cotangent.
No, but you're close. What's the derivative of tangent?
Secant times tangent.
Secant squared. No, the one you gave me was the derivative of secant. In other words, the derivative of secant is secant tangent.
So it's cosecant squared.
That's cotangent. In other words, that's why I'm saying the way to memorize this is if you can memorize that the derivative of tangent is secant squared, then cotangent's the cofunction of tangent. So first of all, it's negative. And then what's the cofunction of secant? Cosecant. So it looks very similar. It's just the cofunction, and a negative sign because it's the cofunction.
Okay.
So that's minus cosecant squared of x minus what? What's the derivative of 2 cosecant?
So cosecant will be changed into negative cosecant times cotangent.
Yes. So it's 2 times negative cosecant cotangent, which makes that positive. Now I have to evaluate that at pi over 2. And we don't need the 2. I don't care what the y coordinate is. I want y prime at pi over 2. So, what's cosecant of pi over 2?
Cosecant over pi over 2.
Remember the way to do these. Make it minus 1 over sine squared of pi over 2. That's the way to do it. If you struggle with these secondary trig functions like most people do, just always turn it into its reciprocal.
Okay.
Now what's the sine of pi over 2?
Sine of pi over 2. I forgot the unit circle.
Well, you don't need the unit circle as much as you need to remember that. Pi over 2 is right there.
So 0? Oh, no, not 0, 1.
Exactly. So it's 1 squared, and the negative sign stays there. So it's minus 1 plus 2 times what is the cosecant of pi over 2?
Cosecant of pi over 2. Would it be negative 1?
No, positive 1. In other words, the cosecant is just 1 over sine. So whatever that is, well, we just figured out that sine of pi over 2 is 1. So that's positive 1. So that's positive 1. Time, what's the cotangent of pi over 2?
The tangent, that would be 1 over tangent. I really forgot my graphs.
Well, there's a problem here. And that is the cotangent of pi over 2 is undefined. In other words,
How is that?
well, because it's 1 over tangent of pi over 2, and that's infinity. Which means that's 0. It's not undefined, it's 0. So cotangent of pi over 2 is 0. That makes this entire term 0, and my answer is minus 1. Now let's check at that. Look at the red line. Does that look like a slope of minus 1?
No.
It does, actually. It's a 45-degree angle, and it's a negative slope. So, yeah, that makes a lot of sense. Always do that ballpark check. In other words, always make sure that we're not looking at a positive slope, first of all. We're not. Now, did you have to find point Q also?
Correct.
Okay. So again, we're going to take the derivative, but instead of evaluating it at an unknown point, we don't know where point Q is, even though it looks like it's 1, we're going to say that the derivative has to be 0 there, because it's a horizontal tangent line. So now I have to solve this equation. And solving that equation means that might be easier said than done. Let's see. We got 2 cosecant x cotangent x. And if I take the other term on the other side, it becomes cosecant squared of x Yeah, we can solve that. In fact, I didn't need to take it on the other side. Better off if I leave it over there. Now let me start again. I'm setting that equal to 0. Okay? Well, this looks a lot like a quadratic that can be factored. Is there a greatest common factor I can take out of there?
Cosecant, not say no. Because that's a cosecant squared. Or could I take cosecant out?
You can take a cosecant out.
Even though it's negative?
Yeah, watch. As long as you end up with the same thing, that's the secret.
Oh, okay.
In other words, I don't care if it's positive or negative. You can take either one out. But the fact is that that's the same thing as I started with. Correct?
Yes.
Okay, that's all that matters when you're factoring. Make sure you get the same thing you started with. Now I can solve it because I got the product of two things equals 0. So I know that either cosecant of x equals 0, and where does that occur? That occurs at, let's see, that's 1 over sine. So, where is cosecant x equal to 0? Let's see, cosecant sits on top. It's never equal to 0. Remember what the range of cosecant is. Greater than 1 or less than minus 1. So this thing is never equal to 0. So we ignore that solution. And the other solution is where minus cosecant x is equal to minus 2 cotangent x, or plus plus. Now, this isn't that easy to solve either, is it? It's always tough solving trig equations when you have different trig functions. If you can get everything into the same trig function, then you're a lot better off. Well, let's see what we got here. Cosecant is 1 over sine. Cotangent is cosine over sine. Bingo. My denominators are the same. My numerators have to be the same. Means 1 equals 2 cosine, means cosine equals 1/2. That occurs when x is equal to 60 degrees. Or pi over 3. Now, is that pi over 3? Well, kinda. I mean, it looks like it'd be pi over 4, but certainly it could be pi over 3. It's in the ballpark for pi over 3. Unlike where it looked like it was going to be, it was at 1. But not so. All right. So that's the way you do those two problems. And those are two classic trig or calculus problems where they want the slope at some point they give you, and they also want to know where the slope is equal to 0. And both of them involve taking the first derivative. One is evaluating it at the second point, and the first one is setting it equal to 0 and figuring out where Q is. All right, are we doing 46? Is 46 the same function?
Yes.
Oh, shoot. What was my y prime?
So right now y equals 1 plus square root of 2
Well,
cosecant.
we're gonna need to. Oh, it's a different function. It's this function over here. Okay, good.
Get to the right of it.
I thought it was the same function, in which case I wish I hadn't ever erased it. Okay.
Okay.
So what's y prime? Always the first step.
So we get rid of the 1.
Okay.
Then there's a square root of 2 cosecant. So cosecant will turn into negative cosecant times cotangent.
Okay, so it's negative, and the root 2 doesn't go anywhere.
Nope.
Times cosecant x times cotangent x plus, what's the derivative of cotangent x?
Negative cosecant squared x.
Negative cosecant squared x. And here I just need to evaluate it at pi over 4. So, in other words, oh, no, it's the same problem. Also figure out where it's got a 0. Well, let's do the first one. Evaluate it at pi over 4, which means minus root 2 cosecant. I'll just write everything out, and then I'll go back and figure out what they are. All right, let's start with what's the cosecant of 45 degrees? Here's my 45. 1 root 2. Cosecant's the inverse of sine. So instead of 1 over root 2, it's root 2 over 1.
Hypotenuse over opposite.
What's that?
That was the same hypotenuse over opposite.
Right. So let's see. It's minus root 2 times root 2 times cotangent of pi over 4, which is what?
I believe root 2, that's 2, negative 2.
You're close. Use my triangle instead of yours. 1 over 1. You said it right. You said root 2 over root 2. But cotangent is the reciprocal of tangent. So if tangent is 1, cotangent's 1 also.
Gotcha.
And cosecant was root 2, so it's root 2 squared. Now, notice that what we have over here is also root 2 squared. So that's minus 2 minus 2 minus 4. Now, look at the red line. Does that look like a slope of minus 4? One that goes through P on 46.
Since it's going out of 45 upwards, yes.
Yeah, and in fact, it's up 4. No, I don't know that I can use that method. But yeah, it certainly looks like a slope of minus 4. It's steep and it's negative. Okay, so now the second problem we want to do is set y prime equal to 0. Instead of evaluating y prime at a certain number on the x scale, let's figure out where q is. And the way we figure out where q is we set, because we can see that's a horizontal tangent line. So we do the same thing we did on the last one. Well, first of all, let's factor out a negative sign. That makes that plus, that plus. Now, let's factor out a cosecant x. Cosecant x, leaving behind square root of 2 cotangent x plus another cosecant x. Well, again, that can't be 0, so that's not a solution. So the only solution is that equals 0. Well, gee, square root of 2 cotan x has to equal minus cosecant x. Last time I converted them both to sines and cosines to make it a little easier. Let's try that again. Cosine x over sine x equals minus 1 over sine x. What's the next thing that has to be true?
So negative cosecant x over sine x. Is there any way we can convert that?
It's not negative cosecant x over sine x. It's negative 1 over sine x.
So that means that's cosecant? Or,
here's what we have, Taylor. Right here.
Okay.
We got the same denominator. What does that mean we can do?
We can combine them.
No, we can set the numerators equal. If I have a fraction equals another fraction, and both fractions' denominators are the same, well then the numerators have to be the same. So I can say square root of 2 cotan x has to equal minus 1, which means cotan x has to equal minus 1 over root 2. Where does that happen?
Negative 1 root 2.
Well, it's negative 1 over root 2. That's not one of your common angles. You have your calculator?
Yes, I do.
Find out where the inverse, it's an n-spire, right?
Calculator?
Yeah.
I was going to use my iPad calculator, but I can grab my graphing calculator.
Well, you just need to be able to do inverse cotan. Actually, here, you don't even need to do that. Let's do inverse tan of negative root 2. What's it give you when you put in inverse tan of negative root 2, which is what we're looking at here. If the cotan is negative 1 over root 2, that's the same as the inverse tan of negative root 2.
I'm grabbing my calculator.
Some calculator that lets you do inverse trig sequences or inverse trig functions.
So inverse tan. How do I get to inverse tan?
Don't know what kind of calculator you're using, so I don't.
Oh, I found it. I got it.
Okay.
Inverse tan minus square root of 2.
It's not minus. It's the inverse tan of negative square root of 2.
Okay. I got negative 0.95531.
It's hard to tell if you're in radians or degrees.
I'm in radians. Should I go to degrees? Yes, for degrees.
Not necessarily. Let's see. Where is that point? That point is, that's like pi would be 3.14, so it's less than pi, which puts it in the second quadrant. I'll tell you what, let's work in degrees.
In degrees, it's negative 54.7.
Okay. Makes so much more sense when we're in degrees, and especially if there's no pi in the answer. So that's where point Q is. Is it minus 54 degrees? Now, clearly the x-axis is labeled in radians. So we really would actually prefer a radian answer. And I don't appear to get a radian answer, oh yeah, that's minus almost 1 radian, which is not what we have. Somewhere along the line I messed up a sign. No, I messed up more than that. I got a feeling when I took off that negative sign and those two negative signs, I can't do that. Oh, yeah, I can. Yeah, I can. Huh. Well, I don't know. We're going to have to leave it for now without a satisfactory answer. Our answer doesn't match our graph. In other words, clearly they have a plus angle where Q is. What is that angle? It looks to be like 3 pi over 4 or something. Whatever gives you a number of about 2.4 radians, which would maybe be 3 pi over 4. I'd be tempted to guess 3 pi over 4. I kind of hate it when they label the x-axis in both radians and numbers, although I understand it. I mean, I see why they do it. A radian really is a number. There's nothing different about radians and real numbers. That's what radians are. Even though we call them angles, they're actually real numbers. So anyway, I'm sorry we only got to those two problems. But
that's okay. Those are the main ones that I needed to go over.
Okay. Taylor, good luck on your quiz. I'll talk to you next time.
Thank you. Sounds good. Have a good day.
You too.
Bye.